So in other way, I can say like object 1 is basically pointing to this block, right? That is where pointer concept comes into the picture. So now it's working fine, right? But there is a problem. What is the problem? So let's say if I am having, hey there, so I have appeared for a lot of interviews, but there is one question I can think of that was asked to me most of the time, that is, what is the difference between deep copy and shallow copy in the context of JavaScript? That's why I decided let's create a video on this, right? So in this video, I will teach you what is the difference between deep copy and shallow copy with example and animation. So this is Gaurav. Without wasting any further time, let's jump right in. So let's understand now what is the difference between shallow copy and deep copy. So here we have copy. That means we are trying to copy something. Let's see that. So for that, you have to understand the primitive data type that we have in JavaScript. So in JavaScript, we have some primitive data type, and those are like string, number, big int, boolean, undefined, symbol, and null, right? So these all are the primitive data type that we have in JavaScript. So in every language, almost like if I talk about Java and others, we have some primitive data type. So because of primitive data type, one language, even though they are object-oriented language, but one language cannot be 100% object-oriented language because of this primitive data type. Okay, so what happened in primitive data type? Let me show you one example. Let's say I am taking one variable x and I'm storing here some number, let's say 10. So I am taking it primitive data type, right? It's a part of number. And then I am taking one more variable, let's say y, where I am storing x. Okay, so I'm copying it, right? And then I'm trying to print both of them in console. Let's say I'm printing x, and the same way I'm printing y. So if I do so, and if I just save it, if I try to run it, what we will get? We will get both as 10. That is fine, right? Now what if I try to change y now? Instead of 10, let's make it 11. Okay, if I do it, what would be the value of x and y? Okay, so value of x is 10 and y is 11, right? Because we are changing value of y, we are not changing the value of x, though we have copied the value from x to y. That is, so this is the one scenario that we have seen for primitive data type. Okay, so now let me show you one strange thing that we have for non-primitive data type. So in JavaScript, non-primitive data type are those which are object. So here we have like the object is basically the non-primitive data type in JavaScript. Okay, like we have function, arrays, these all are nothing but object in JavaScript. So apart from primitive data type, everything is object in JavaScript. Okay, so let's try to do the same example using an object here. Let's see what happened in that case for non-primitive data type. So here, let's say I am taking one object, let's say I'm giving name object 1, and here I am storing some value. Let's say I'm storing name. Here I'm giving name, let's say John, my favorite name actually. And then I'm putting some age, let's say I'm giving 22. Okay, this is my object, and let me just copy it into another object called object 2. Here I am copying object 1. Make sense? And let me print both of them now first. Okay, so this will be my object 1. Perfect. So now if I save it, then what will be my output? My output would be in the both cases John and age. That's fine. Now let's try to do one thing. Let's try to change the age of object 2. So I am changing the age from object 2 from 22 to 31, let's say. Okay, so if I now save it, let's run it. See, here something happened which is strange, where we need our attention. See here, I am changing the age of object 2, right? So it's fine, it should be 31, but you can see here also the age is changed. Instead of 22, here I can see 31. So which is not happening in case of primitive data type. So that is the main difference between primitive and non-primitive data type. So for primitive data type, we are copying the value, right? That's why even though we are changing the value of y, x is same as it is. But in case of non-primitive data type, we are not copying the value here. We are copying something called reference. So now let me show you one animation which I have prepared for you. Now let me show you how basically we are copying the value for primitive and non-primitive data type. So let me show you that first, and then we'll come back to this topic again. So now let's talk about memory block that we have in our computer. So you can imagine out in this way, like we have a number of small block in a sequence, and this is forming the memory where we are storing the data, okay? And the smallest block, you can see this is the smallest block. This block can store either 0 or 1. It is nothing but a 1 bit of information. So a single block or smallest block can store 1 bit of information, not more than that, okay? So now if I talk about, let's say you are having 1 TB of hard drive, so you can calculate how many bits you have available. So from 1 TB to GB, then MB, then KB, likewise in bytes, and then finally we have bit. So here I can see we have 8 into 10 to the power 12. So after it we have 12 zeros. That many number of small block available where we can store 0 or 1. So that is how our memory block look like. And every block is having an address. You can call it as reference or sequence number. Like this is my 0th block, and then 1, 2 likewise. And let's say this is a final block we have where we have 8 and then followed by 12 zeros. I can't show you all this block here, so that's why I'm trying to show it like this. If I talk about a block in middle, let's say it is having the address or reference 1050, okay? I hope now it is clear to you. Now if I talk about memory allocation for primitive value or data type, so it is happening like this. So let's say I have x equal to 10, which is a number, that means primitive data type. So first, in order to store the value 10, first it will be stored in binary format, right? Because it's a decimal format and computer will only understand 0 and 1. So here let's say my 10 is being converted and it is being stored in this memory block. So let's say it needs 4 block likewise. Ideally it will need more than that, but let's say it is taking 4 memory block or smallest block from the entire block. And this is my x, okay? In x actually we are having this binary value, that is 1010. If we convert 10 to binary, you will have 1010. Now let's say I'm copying the value x into y. Then what happened? Then another set of block will be occupied in the memory, okay? That is also 1010 into a different location, okay? So that is now my y. Now it is having 1010 again. But there is no link in x and y, right? Because they have stored into a different location. So that is the main property of primitive data type. We are copying the value, okay? Now if I let's say make some changes in y, let's say I'm changing the value y as 11, we are not doing anything in x. So this bit, last bit, you can see from 0 it will be 1. That's how it's happening. But there is no link in x and y, so x will be as it is. So if I try to show the same for non-primitive value, here the strange thing come into the picture. So for non-primitive, let's say here I'm having an object. In object I have name. So first that object value will be stored some places. Let's say it is taking 4 block, okay? Now each block is having some reference or address, whatever you can say. Let's say the base address, mean the starting address here is 2050, okay? So that is now will be stored in our variable object1. So object1 is basically storing the base address or reference of this entire block, okay? So from where it can access the other block too. So object1 here is not storing the actual value. The actual value is already stored and it is storing the reference or base address, okay? So let's say I am just copying object1 in object2. What will happen? Then object2 will be created, and here object2 will be having the same base address that object1 is having. So I can say the object2 is also pointing to the same location where object1 is pointing, right? So for object2 we haven't created any separate block. The block is created only once. It is just sharing the reference in object2. So now if I made some changes in object 2, like if I change from 22 to 31, then we are pointing to the base location. So through that we will change the same in object 2 and object 1. See, object 1 here it was 22, now it is changed to 31. That means, so as it is pointing to the same location, so through object 2 we can change the content. So again, object 1 is also pointing to the same location. So in object 1 also we can see the changes. That is what called, it is sharing or copying the reference. So that is where there is a demand that for object also we want to have copy. Like we want that object 2 will be having another copy of object 1. It should not point to 2050. That is the demand, right? We have to copy object 1 value, not the reference. So that is where shallow copy and deep copy comes into the picture. How we can achieve it, that is what I will show you in this video. So now let's go back to my VS Code. Okay, so now the requirement is clear, right? So currently the reference is being copied, so I want to copy the value. How we can do it? So it's very simple. Let me just comment it so that I don't need this output anymore. Let me just clear it as well. So now in order to copy the value, not the reference here, I can use something called spread operator. So I know you're using it very frequently. It's a very famous operator. So if I write like it, what happened? The field will be spread out and it will create a new object or copy of object, and that will be stored in object 2. So now if I save it, then the age in object 1 will be different. See, here age is different here, 22. But here the age is 31 because we have made the changes. So right now the reference is not getting copied, but the value is getting copied. That is what we want. Okay, there are other way also we can achieve it. So that is like if I like let object. So here that's the second way we can do it. So here I can write object dot assigned. Okay, so I'm giving a blank object, okay, where my value will be copied, and here I'm giving the object 1, the content from where the content will be copied. Okay, so if I just save it and rerun it, we'll be having the same result. So this is a way we can copy the value from one object to another object. Okay, so now it's working fine, right? But there is a problem. What is the problem? So let's say if I am having address here, okay, and inside address I'm having another object, that is what called nested object inside one object. So here let's say I'm having city Kolkata, that is where I am right now. Okay, and let's say I'm writing country India. Okay, so I have added one more object which is a nested object. So if I do it, and instead of age, if I now try to change address city here from Kolkata to Delhi for object 2. Now what will happen? So ideally we want that for object 1 the city should be Kolkata, then only you can say the value get copied, not the reference, right? So if I do it, see, for both the city now we have Delhi, not the Kolkata. So that means this is working fine, but for one level, the outer level it's working fine. But the moment I go inside it in nested, again the reference is getting copied, that is the address. For address, again the reference is getting copied. That's why through this city we can change the city for both object 1 and object 2. So that means this is what called shallow copy. So in shallow copy we can copy one object into another, but in outer level, only up to one level. One level means we can only copy name, age, that's it. But if there is anything which is nested like city, country, we can't copy it, because here also the reference will be copied. That is what happened right now. So now the question will come, how can I copy this object entirely? Doesn't matter how many nested objects we have here. So that is where we have the concept of deep copy. So in shallow copy, as I mentioned, we can only copy one level. In deep copy, we can copy the exact object from one to another. Okay, so we have one way out for doing it. Let me show this. So this is for shallow copy. Let me write it down. Now let me show you deep copy. So there is one way we can do it, and that is, let's say I am writing let object2. So here I can convert, the entire object we have into string. So let's say I'm writing stringify. Here I'm writing object1, and now again I have to convert it back to object. That's why I have to parse it. There I can use json.parse. Okay, so now I have done this. If I save it and run it again, see, now it's working. So for object1 I can see Kolkata, that is what I expected, but for object2 it is Delhi because we have made the changes. So now I can say we have copied this object fully, even though we have some nested object here. But there is one more problem. You know what? So let's say if I have some function here, and that function name, let's say get BMI, something that will calculate the BMI of the user, whatever. And there, if I try to have one function here, and let's say that function is returning some number. Okay, I'm just writing something because here it will do some step, some calculation, and then it's returning something. So if I have a function here, okay, because we have resolved the nested problem, right, through this way. But what happens if I have some function here? So in that case, if I run it, there will be problem. So you can see for object1 I can see the function, right, but that is not copied in object2. So through this approach we cannot copy the function if one object is having, right? So we are trying to do deep copy, but somehow we are not able to do, right? So that is where we can use some third-party library called loadash. So I will show you how to use it. So now we will do deep copy using loadash. So for that you just have to go here and search loadash npm. That's it. You will find this official page. You have to open here. So now we have to install loadash. So here I can copy this command that will install loadash. So you can install it globally as well. So for now I am doing it locally. So I'll just write npm loadash and enter. So then what happened, one package.json file will be created. So let's wait. So now it is installing loadash. You can see node model is there. That is where we have all the packages or dependency for loadash. So let's see how to import loadash. You will find it in documentation. This is how I will import loadash. So I'm just writing this statement here. Okay, and now I will try to do deep copy with loadash. So deep copy. So here the same way I will write my object2 equal to, it gives us one method that is called clone deep, this one. Okay, and here I will write object1. That's it. So now if I run it, so now you can see here the function is successfully copied in object2 from object1. That happened because of clone deep, which is provided by loadash. Now if you try to do the deep copy manually, it will be very difficult because you have to write a lot of loops. Let's say there are a lot of function, lot of nested. So that's why we are using clone deep. So I hope you got the idea now what is the difference between shallow copy and deep copy. So now if anyone will ask you in interview, you should give them the right answer. So shallow copy or deep copy. So normally for non-primitive, that is for object, the reference is being copied, not the value. So for shallow copy, we are trying to copy the object, but it can be copied only up to one level. If there is any nested object present, then it will not be copied. But in deep copy, we are copying the entire object. Doesn't matter if there is any function, if there is a nested object or what. Okay, so there is a demand where we have to do it. Okay, when we will work in real life project, you will understand. But yeah, that's what I decided to share with you. So if you like this video or if you have any question in the video, please mention that in the comment section. If you want to know about any concept, let me know in the comment section as well. That's all for this video. See you in the next video. Thanks. Take care. Tata. Bye bye.